Hello everyone, this is Mrs. Logus and I will be taking you through numbers 1 to 7 in the cumulative review packet number 1. I hope that this will be a helpful resource for you. So if we look at number 1, we're asking, is the point 1, negative 3 a solution to the following equation? And when a point is a solution, that means that it makes this equation true. So to see if it's true, we could plug 1 in every time we see an x, plug negative 3 in every time we see a y, and see if both sides equal 3. That's exactly what I'm going to do. 1 to the 4th times negative 3 squared plus 2 times 1 squared times negative 3. Does that equal 3? I'm putting a question mark there just to see if it's true. If I continue to simplify and use the order of operations, I want to do all powers before I multiply or add. So 1 to the 4th is 1. Negative 3 to the 2nd is negative 3 times itself, which is positive 9. 1 squared is 1. And then we just have a negative 3 here. Does that equal positive 3? Multiplication before addition. So 1 times 9 is 9, plus 2 times 1 times negative 3, negative 6. Does that equal 3? Well, 9 plus negative 6 is 3. So I get the statement 3 equals 3. Which is always true, so I would say absolutely 1, negative 3 is a solution, which means if I graphed this, this point would be on the graph. Number 2, the hefty problem, having to do with a scatter plot. The first thing we'd like to do is plot all of this information in our calculator. And so if you don't have your calculator out, now's a good time to do this to make sure that you're doing it correctly along with me. So I'm going to pull up my TI calculator, and the first thing that's asked is to plug all this information into a scatter plot. So if I pull up the calculator here, first thing you want to do is press Stat and then go to Edit. Before we're starting to make the video, I already put all the information in. So if you have not put the information in yet, I would like you to pause now and do so. Now that the information is in, I want you to press Second Quit. I would also want to make sure that your stat plot is on. So if you press second, y equals, please make sure that this says on. If it doesn't, please make sure that the on is highlighted. Then you can second quit again, and now we can press graph. Now if you're like me, you're not going to see your graph. What you need to do is go to Zoom, and then I believe Zoom stat is number 9. I'm going to scroll down and make sure. Correct. If you press Zoom stat and your stat plot is on, you should be able to see all of the points that you just plotted. And now that I take a look at my graph, I notice that the points are increasing. If I was going to draw a line of best fit, it looks like my line has a positive slope from left to right. And so part B asks, let's describe the variables and how they're related in the above situation. And we want to decide what the variables are, what represents x and y. So again, it looks like as x's are increasing, y's are increasing. So let's think about what that means. If in this problem, the hours of sleep are x and the math test scores are y, our line ended up looking like a positive slope. So as the hours of sleep increase, it seems that the math score also increases. And so when we are describing, we generally want to start with the phrase, it seems, because we're not exactly sure. It's more of a correlation, not a causation. So what I'm going to write is this. It seems that when a student gets more hours of sleep the night before a test, the higher the test score. So I may have accidentally chosen this for a reason. So before next Tuesday, it is very important for you to get good sleep. And that goes for any test, by the way, ACT, anything coming up. Remember that a good breakfast and good sleep is exquisite. okay, I'll stop now, but may have done this for a reason. Okay. Part C, use a calculator to create a linear regression for the data, aka a line of best fit. And we want to find what the equation is. So I want to remind you how to do that on the calculator. So if I bring that back up, go to second quit, what you want to do is go back to the stat menu, but now scroll over to calculate. You want to press 4 for the linear regression. Now everyone's calculator is going to look a little different. When I press enter, mine pops straight up. If you have the R values down here, you don't need to worry about them right now. If you had to scroll down and press calculate, that's okay. Just make sure to press calculate down here. And we all should get somewhat of the same answer here. So A is my slope and B is my y-intercept, which means my equation would be y equals, let's do a little bit of rounding, 3.6557x plus 55.1475. Notice I kept a good significant amount of digits because the more that I round, the more off my answers are going to be. So I would keep a decent amount of decimals. Now, based on that equation, we would like to interpret the slope of the linear model in the context of the data. And remember from earlier, we said that y was your test score and x was the hours of sleep. So if my slope in the problem is 3.6557 over 1, in terms of units, remember that slope is really rise over run or y over x. So that means we're dealing with your score comparative to the hours of sleep that you get. So if you need to interpret what this slope means, remember that your slope of your equation was increasing from left to right, so something's rising. So if we had to put this into words, I would say something like this. For every hour of sleep, the math score increases by somewhere between 3.6 and 3.7%. So for every hour, that's about a 3.5 to 4% increase, which is pretty significant. What we also want to do is interpret the y-intercept. And if we look at our equation, the 55.1475 is my y-intercept. If I write it as a point, 0, 55.1475, we need to interpret what this means. Again, units still matter. The x values are still hours of sleep, and the y values are still your test score. So what this means to me is at 0 hours of sleep, your score would be a 55%, which means you definitely knew something before you walked into the test, though, because you're still getting a 55%, over half of it correct with no sleep. Not terrible, but I'm sure a lot of you want to do much better on this test than that. So, if a student gets no sleep, they will earn a 55% about. Part F, use your equation to predict the math score on 3 hours of sleep. So what we want to do is take our equation, and if we're dealing with 3 hours of sleep, remember that hours is an x unit. So that means I'm going to plug x into my equation, or plug 3 in for x into my equation. So I'd have y equals 3.6557 times 3 plus 55.1475. If I plug this into my calculator, the answer that I got was 66.1146, which means that on 3 hours of sleep, you get somewhere between a 66 and a 67%, or a D+. Does this value make sense? I would say yes, because when I looked back at my data, if I'm looking at 3 hours, the lowest value I had here was 5, and we had a 70%. So it would make sense that something lower than 5, the 3 would be lower than a 70%. So I would say, yes, that works with my line of best fit. And the other question, is this interpolation or extrapolation? Well, if we take a look back at the data here, the 3 is outside of the data set that we had originally. So between the two, I would say that this is extrapolation because the data is outside of the original set. Lastly, for this problem, use your equation to predict the number of hours of sleep a night before a test if a student earns a 60%. So this time, whenever you're dealing with a percent or a test score, that is a Y value. So you're going to do the opposite thing that we did on part F. We're going to plug 60 in for Y, and we're going to solve for X. So this says 3.6557. So now if I subtract the 55 over, I would get 4.8525 equals 3.6557x. If I divide both sides, sorry about my marker here, it's being not as neat. I got my x value to be 1.327, and x is in terms of hours. So I would say a good answer is you would be getting somewhere between 1 and 1.5 hours of sleep. That was a long problem, but I wanted to be thorough to go through everything so that you can look back on this and use it if need be. Okay, thanks for sticking with me through that. We probably have time for one more on this video. We'll do number 3. Graph the following by making a table. Okay, there's actually 2 ways we can do this, but if we want to use a table, we can pick any x and y values we want. I'm going to do a little bit of negative, a little bit of positive. So just to be safe, I'm going to start with -3, because it's good to have a lot of negatives just to start. If I plug all of these values into the equation, I should get my output values. So that would be 2 times -3 squared plus 4 times -3 minus 6. So that would be 2 times 9 minus 12 minus 6. 18 minus 12 is 6, minus 6 is 0. So I have the point -3, Done. If I plug -2 in, 2 times -2 squared plus 4 times -2 minus 6, that's 2 times 4 plus -8 minus 6. So that's 8 minus 8 minus 6. So this is a -6 output. So my next point is -2, -6. If I plug -1 in to save a little time, -1 squared is 1 times 2 is 2. 2 plus -4 is -2, minus 6 is -8. So -1, -8. If I plug 0 in, I get -6. If I plug 1 in, I think it's going to be somewhat of a mirror image now, because notice we have -6 on both sides. So now we're going to have a 0 on both sides. Check me if you want to. And then lastly, if I plug 2 in, 2 times 2 squared plus 4 times 2 minus 6. That's 4 times 2, 8, plus 8 minus 6 is 10. So I have my last point of 2, 10. And so before the problem started, I knew this had to be a parabola, and a upward-facing parabola, because the lead coefficient is positive, and I have a squared term. So there's my graph. Now that I have my graph, I can answer these questions. The x-intercepts are the places I cross the x-axis. We see that here, and we see it in the graph. -3, 0, and 1, 0. The y-intercept is where it crosses the y-axis. 0, -6. The vertex is where it turns, which is at 1, -8, -1, -8. And lastly, the axis of symmetry is the line that cuts this parabola in half, which would be a vertical line. So that would be the line x equals -1, because it goes directly through this vertex. If you're interested, you could have also factored this original problem. And if you had factored, you would also get these roots. So that's the time for the first video. I will start the next video with number 4. Thank you.